Today we will be talking mainly about Python and how we can leverage the power of Python in analytics. And while I might be talking a bit technical about Python and the related jargons to it and its different application in different fields, but people can come to me and ask me about if they want to talk about career-based guidance, or if they want to understand why they should learn Python and so on. So that's the main agenda. So Sushil, without further ado, I'll move into the uh, presentation. So thank you for the introduction, and let's head in. So I think Sushil has already given a brief introduction about me. You can also reach out to me in LinkedIn if any of you want to do it. And so I'm also AWS certified. So in case if any of you need any help in understanding what's the value of these certifications and why you should do these certifications, we can also discuss on that also. So let's go to the next slide. So the basic question that comes into anyone's mind when they are, trying to understand, uh, like what kind of programming languages they should choose and why they should choose. So you have a plethora of options, right? You have Ruby on Rails, you have C++. You can also look at Objective C, and there is different kind of frameworks around it which you can use. But like I would personally choose Python if I am somebody who is very new to programming and I am trying to learn the basic things about programming, like why I should learn Python, what kind of things I will gain from Python, etc. So let's go next, and then I'll talk about like how does Python rank, like if you go to the uh, different kind of organizations, specifically which we refer to as FANG. So we have Google, Facebook, Instagram, Spotify, Quora, Netflix, and one major thing that you will see is that all of these, platforms, or rather all of these, companies that you see here on the screen, they use Python for their research. And it's not, limited to research, but they also use it for testing out different kind of APIs and how they would, interface with the front end, etc. So this is a chart on your left that actually tells you about the popularity of a particular programming language, and you will be pleasantly surprised to see that Python ranks first in this. So you might be a business analyst, you might be somebody who is aspiring to be a data scientist, or somebody who handles Excel sheets on a daily basis for doing multiple activities. You can use Python for almost anything right now because there are lots of libraries, and I will slowly get into the advantages of using Python. So, what's in it for a learner? So, you know, Python is very easy to learn. It's basically like English. You don't need to write a lot of code heavy things, unlike other programming languages. You have the second largest community of coders in the entire world, and also you get a big advantage, which is like the syntax is very clean. So unlike very uh, traditional programming languages like Java and C and C++, where you have to type in the words, you have to declare the variables, and also you need to close each code block just to make the compiler understands where things start. That's not the case with Python. Python is an interpreted language, guys. So you get a Python shell along with it, and Python actually executes each line of the code line by line instead of compiling the entire code and then telling the compiler to pass it on to the machine to execute it. That's not how Python works. It's much simpler than that. And Python has a lot of comprehensive standard libraries. By comprehensive standard libraries, I mean stuff for doing daily stuff, like if you want to read Excel files, if you want to do certain mathematical operations, if you want to multiply, divide large numbers, you want to handle a huge array of numbers, you want to read images, all kinds of different kinds of stuff. So you have a standard library that is already present inside it. The next big thing is i- documentation, because with any kind of coding framework or coding library, we need a lucid documentation. And with Python, it is very easy. It's very, simple. You can go and check out the individual libraries websites, and you will find that the documentation is extremely lucid. It's very easy to write and execute, and in the documentation you will find that they have a lot of examples also. So that's why, these all things make Python very general purpose. And on top of that, in today's webinar we will talk about two important things, that's list comprehension and Lambda operations. So that's something, I think that makes Python very unique. And before we head out to the next slide, I would also like to show you, like, what are the current size of programming language communities. That was in 2021, and that has certainly increased. You can go check it out yourself. uh, the reference link over here, and you will see that Python was second largest back then, and I think right now it has crossed that index definitely. So that's all what you get when you think about learning Python. So let's go next. So why is Python so simple? When I think about syntax. So look, you have a machine in front of you, and uh, with any machine, it doesn't understand human language, right? So you need to tell it exactly what do you want the machine to do. It's very important to make it clear. So that's why, in the early times when we had C++ or C, the code was usually compiled. By compiled, I mean, first of all, you write something that's, that has a specific format, and then you wait for the compiler to compile the code, and then it becomes machine code, and then finally you get an output. But things got simpler when we got introduced to Python, because you don't need to write so much. And because Python, with Python, you don't need to write so much. It kind of encourages you when you have a problem. You don't have to think about declaring variables. You don't have to worry about basic input output libraries, etc. So, so if you look at the example right here, I mean, I have on the screen. So, for any kind of programmer, I mean, if you're learning programming, so one would want to write hello world, right? If so, so what does hello world mean? So basically, you're trying to print a statement over here. And if you look at C++, you have to import this IO stream. It's called a, it's called a header file, and you need this preprocessor header files to execute this particular uh, block of code which you see over here. And also you will see that with for output you need to put certain arrows like this, and you have to end every line using a semicolon, telling the compiler that, hey, look, this is the end of the line. And since everything, for everything you need to write a function over here, it's like you have to declare the type of function you want. You have to tell the compiler, like, look, this is the main function. And since you are telling that the function is an int, you need to return something which is an integer, so you return 0 at the end of it. And this makes programming very complicated for beginners. And now I'm not telling that C++ is a bad language to start from, but I'm telling Python is little bit easier when you look at such aspects, especially with syntax. And right below it, you can see that I have printed hello world again with Python. Now, this is just a line, and you don't need to declare any preprocessor header files. You don't need to worry about line endings. You don't need to worry about, how you're going to declare it in the compiler. It's fairly simple. It's almost like English language. And if you look at a more complicated operation over here on the right, you will see that I have a loop over here. Now looping is something like, if you're understanding like programming, you will understand that, I mean, it's something you need to do very often. And uh, you need to worry about increments, you need to worry about the number of times it's going to loop, and you need to also think about where it's going to start. So this makes looping kind of very difficult for a beginner, because you have lots of things to take care of. And also you need to worry about, whether you want to increment it before, like you want to subscript it, or you want to do it later on. And again, these are some of the different factors that you need to think about when you're using looping in a traditional programming language like C++. While for the same thing, if you look at the code on your left hand corner, I'm doing the same operation, which is uh, taking the square of first 10 integers, from 1 to 10, and it's also printing it. Now here I have used something which I call as list comprehension, and I will get to it later. But you can fairly see that how does it look like. I mean, it's so simple. You're basically telling Python to square it, and you're also declaring it as a an array over here. So we refer to as list in Python, but it's definitely much more efficient than what you would do in C++. So this is another example in front of you. So XML serialization is something, quite commonly used when you're handling any kind of microservice or any kind of web application, or any kind of security based, interface also. So you can see the difference, guys. So this is 130 lines over here, and it's 1580 lines over here. So the same amount of code, it's it's taking so much of less space. And that's the advantage of using Python. So if you are somebody who is new to programming, you are learning Python, you won't be discouraged as much. You can think about solving huge problems. And I'm not saying it is the fastest way. I mean, like, it is actually the fastest way to implement this. Definitely, Python is a lot slower than C++ for some of the codes. But given the current version of Python that we already have, it's much more faster than this. And similarly, for reading Excel files for any kind of data analysis, you can see that it's 76 lines in C++ code, and it's just 2 lines in Python. And I will get to this data structure, which we commonly call as Python. Sorry, it's called as pandas. And as a data science, we use it very frequently. I also use it for, even though I don't have a data science problem, if I have to read a lot of Excel files, make certain changes in it, it's much more faster than opening an Excel file in, MS Excel or Google Sheets, and then trying to do that same operation. It's visually much more easier, and also you can execute a lot more faster also. So let's go next. So for any kind of programming language, uh, if you have heard about algorithms, so algorithms is pretty old. Like, you get introduced to it when you are in school, and you write something which is called as a pseudocode. Now, what I mean by pseudocode is something that you need to write before, understanding what are the different blocks in the code. You want to write for yourself and then convert that into code, so that it is easier for you to understand. So it's like you have an idea with you, and you break it into steps, and before putting it into, the code itself, you write a pseudocode which actually looks like the code. I mean, you can write it differently also, but this is usually the format. And if you look at the difference between pseudocode and Python, it's pretty less, right? I mean, look over here. You're trying to figure out if a number is less than 5 or it is greater than 10, and you're telling the user thank you if it fails. So here you can see you declare a user input, you tell whether the number is greater than 10 or it is less than 5, and then you print it. And for handling the input also. So this is another unique thing about Python. You don't need to worry so much about input and output handling because you already have excellent input output handlers built into the basic Python itself. You don't need to install anything. It's that simple. And if you look at another piece of code that I have here, which is like telling that uh, if the number is greater than 10, and also you take the another number which is also greater than 10, and you tell that okay, it's good, thank you, or like you print if this condition isn't met, you tell that it's an invalid input. So basically you are testing out whether the two numbers that the user has input is greater than 10 or not. And you can see the similarity between pseudo code and the Python code itself. And if you look to your left on the table over here, so this description just tells you like, okay, these are some of the basic operations, and you have a Python example over here, and you will see that between the pseudo code and the Python example, you don't have a lot of difference. And this is because Python is syntactically very easy to handle. You don't need to write a lot of code, but it gets the job done. So in case if you are researching something, or you want to understand something new, or you want to try out different kind of libraries, etc., you can go out and check Python. So coming to the next part, which I discussed early on, that's Lambda and list comprehensions, and why I want to talk about these topics. So, in traditional programming languages, you need to declare functions early on, and you need to tell like what kind of operations they are going to do. But Python introduces something called as anonymous functions. Now, I hope that you all must be aware about functions, what it does. It basically takes an input and gives you some output after doing an operation inside it. And to do that, you need to define it. Now, the problem with defining it is you need to go back, you need to write a separate line, you need to tell the operations, and then you need to, call the function, and then you need to get the output stored in it. So it's not that simple. Now, if you have something like anonymous functions, you don't even need to, declare it. And that's what Lambda does. So Lambda is a particular kind of keyword, like you give some input to it, and it will, you assign some operation to it, it will give you the output without putting this in a function. So in fact, it's so useful. If you put different Lambda functions inside a name function over here, you can have multiple operations inside it. You don't need to create different function for every kind of operation. And that's what makes it so special about Lambda functions, because you can declare a Lambda function almost everywhere. And if you see in the top left corner, where I have given I've given a function where it takes an input and adds 10 to it. It's very simple, and I am passing an input to a variable. So this is what makes Python very unique. You don't have these functionalities in other kind of programming languages, and you get an output. So you don't need to worry about writing functions where I will store the output of the function. You can just assign this statement to another piece of code that you have. So it makes coding a lot more faster. And if you are stuck with any kind of data science problem, you can just skip through the formatting part of it and go ahead with using Lambda functions. And on your right, you can see I have given an example of something which I call as list comprehension. Now, not only is this method a lot more faster than in a traditional way where you iterate over different array elements and then do an operation, it's also syntactically much simpler. So, as an example, if you see, I have taken fruits. I have taken an array of fruits over here, and I am trying to figure out, those fruits which have A present in it, and I'm adding it to a new array and I'm trying to print it over here. So by using traditional loops, I have to first of all iterate over these fruits. I have to then search whether that particular A is in X. And just to reiterate again, like these kind of syntactical, bonuses that Python gives you, you don't have this advantage with other programming languages where you are, searching directly in the string. So Python by itself recognizes that, if you are trying to do something within X, it breaks it down and it will search inside it. And that's what makes it so special, and that's why it's so easy to implement such a huge code. Now, to further simplify it, you have something called as list comprehension. So this is the basic format for a list comprehension where you have a list of items, you iterate through it, and you basically tell that whether if the condition is true or not, and then you return something in the beginning. And that's what I have done. So the same operation that I completed using the loop over here, using the primitive method, you can do it using list comprehension, and it's going to be lot more faster. That those are the key takeaways when you start uh, programming using Python. So coming to the different examples of where Python is most widely used, like Python is used in scientific computing, where it's like the uh, you know as the third pillar of science for any kind of if you have theoretical physics or any kind of theoretical analysis. Basically, you do have the data, you have some algorithm present with you, and you want to do certain experiments that might lead to certain kind of scientific discovery, or it might solve certain problem. So Python is most widely used for this purpose. That's why it was introduced. And these are some of the packages that you can look at. So SciPy is something, uh, you know if you like mathematics, or if you are trying to understand vector algebra, you want to calculate distances between two different vectors, do dot multiplication, etc., you can look at SciPy. And you have a similar library called NumPy, but NumPy is mainly used for handling huge data sets, multi-dimensional arrays and matrices. So NumPy is also used with images. We also use something called matplotlib, and with matplotlib you can plot different kind of graphs. So for any kind of scientific computing experiment, you want to understand what it looks like. And it's very easy if you have some libraries like this available, like matplotlib, with you. And what it does is it will help you plot the distribution, understand how the numbers are looking like, etc. Now coming to the next library, which is pandas. So if you are enthusiastic about learning data science, and you want to handle huge columns of Excel data or do certain operations inside it, so you can use pandas for it. So it's a different kind of data structure which is high performance, and it's column based, it's not row based. So guys, you can check this out. And you can also check out symbolic mathematics library. Now that is something which people use it mainly for representations and writing inside documents or presenting purpose. So you can check these libraries out. Coming to the next you know buzzword, that's like data science. So people use it for machine learning purposes, and with machine learning purposes you have something called, you might have seen people calling it as sklearn, and that stands for scikit-learn, where you have different kinds of data sets available that you can use it to test out different kind of algorithms. There is TensorFlow, and TensorFlow became very famous. I mean, if you look at the state of the art models that you have, state of the art algorithms that you have, TensorFlow is used in them. You have different models that are already pre-trained present inside this. So this is what gives Python an edge. So the community has already developed certain models for you which you can directly use, and TensorFlow gives you that advantage. You have PyTorch also that you can look at for any kind of pre-trained models. And why I stress out about pre-trained model is because everybody doesn't have access to a lot of data. So whenever you're doing any kind of data science, you need a lot of data to to draw the actual useful insights that you can get from it. So without the data, you won't be able to train your model and you won't be able to get your required outcomes. So for any kind of POC work or any kind of development activity, you need lots of data. And if you don't have data, you can use these pre-trained models that people have already trained for you, and it will give you very good results given the use case is similar to the data where it was trained on. And when you're handling even bigger data sets, you're handling databases basically, where you have millions of rows. People use clusters for it, and the common layer that sits on top of everything which handles these huge operations is PySpark. So it's heavily used in data engineering, where the scope is, I mean, quite literally endless, where you can use this. You can also use PySpark with machine learning, and you can draw insight on something like big data, what we definitely call it as big data. And that's where Python again shines. And these two have already covered. I mean, for any kind of data analysis, you need to crunch a lot of numbers and a lot of features. And by features, I mean the different kind of aspects about the data. And that's what data analysis means, to draw insights from doing exploration on data. And that's what NumPy and Pandas will help you. And if you look at data mining, so I mean, if you want to gather some kind of data yourself, you can go to the websites and you can try to extract the information from those sites using libraries like Scrappy, PySpider. You also have something called Beautiful Soup, and there is something called a Selenium also. So people who in the QA space might have heard about it. So you can integrate Selenium with Python also, that will actually mimic human clicks, and it will gather the data for you. And that's it, folks. And let's go to the next slide, that is computer vision. So given the current advent of imaging technologies and the kind of algorithms that are available for detecting different kind of anomalies or other features in the data, so computer vision is very useful. So computer vision is concerned with the automatic extraction and understanding information from images. It can be sequence of images, it can be videos. So if you are interested in handling huge image data sets, where or maybe any kind of video analytics where you try to detect different kind of things inside videos, uh, you can look at computer vision. And there are certain packages associated with computer vision. I won't get much into details about it because it's based on image data, and there are different algorithms and aspects behind it. So it's a different field of study itself. So anybody who is interested in understanding different aspects of image data, applied deep learning algorithms, you can take a look at these packages, and you will be able to grasp the help that Python gives you. So who should learn Python? And this is the most critical question. So anybody who is beginner, they can have a look at Python, and any kind of professional uh, who are in the area of embedded systems. By embedded system, I mean if you're looking at any kind of board development, you want to develop RFID devices, or maybe you want to make a smart system based on sensor data. So if any of you are aware about Jetson, etc., so those all things comes also under embedded systems. People have different applications for it. So Python definitely helps when you want to research in those areas as well. Computer vision. So anybody who is very passionate about handling image data, they want to do image analytics. For example, if you want to detect you know a posture present inside a particular video, or you want to understand what's the running the stance, or like the gait of a walk of a person, how does a person walk. All those different kind of security based features are done using computer vision. So those are few of the examples. And also you have something like optical character recognition, etc. You have digit recognition, gesture recognition. So those all different aspects come under computer vision. And there is one exciting site also called This Person Doesn't Exist. So if anybody wants to get inside generative networks also, that will generate images of random people for you which do not exist. They can also look into computer vision. I definitely find this very interesting for folks that are interested in data science. And that's not just covering basic machine learning algorithms. You can cover NLP use cases, and you can cover different image based algorithms also present inside it, so those people can have a look at different data science applications. And web developers, definitely, I think I mean people who are developing in the web for a very long time, they might be already aware of the advantages that Python offers and how you can interface it with existing pipelines. And also it's useful for general software engineers. I mean, for generic stuff, you want to test out one algorithm, you have an idea, you go and check it out. You can make APIs with it. For system administrator, I have done it myself. Like, you can try and integrate it with sub process module, and you can use it for shell commands. You can do lots of various things for system administrators also, etc. So these are some of the few areas that I deem very useful to cover, who are trying to learn Python, and why you should learn them, different kind of areas that Python covers. So this is the ranking of IEEE spectrum. So there are 11 metrics around it that gets measured, and it basically tells you like which is like the top programming language. And this is I think the last quarter of 2021, and you will see that Python scores 100 in this, and it's used for web development, UI, and also core development. Those are a few of the areas, guys, and you can check it out. And it's actually gathered from 8 sources, so it's definitely worth a look to understand not only that where you are lacking in Python, but what are the different kind of technologies that you can learn with Python. It will also tell you how people are using this language, so it might give you an insight, okay, like what you might be interested in, if something like that interests you, I mean, from these posts. So coming to the last part of it, which is the Q&A session. So if any of you have any questions, or if you want to discuss certain career aspects of other things like data science, etc., please feel free and forward your doubts in the Q&A itself.
Okay, the floor is open to the audience. If you have any questions, please share them with us, and our presenter will address it right away. Amit, there is a question. Yeah. Can you
Okay.
explain the career progression in this field? Hello?
uh, okay, like, by career progression, I mean, if you are talking about
Like
data
for a
science, or
fresher of sorts?
okay,
Like
so
where
if
do
you,
we
if yeah, I mean, if you are a fresher and if you're looking for a career progression, I mean, it depends on your background. So if you are new to programming, and you're searching for jobs, you have a different field that you did your masters, or like your bachelor's, you can start learning about different technologies in Python. And I would personally recommend you to take uh, a guided approach that would tell you like what to do, what are the different kind of modules you need to follow. And to help you with that, you can take a look at the community of people that might be also training with you, that might also give some ideas. And once you have the questions in your mind, like what do you want to do and what actually interests you, you can start pursuing that in, either you try to learn in Python or like any programming language of your choice. But it's easier if you are taking the route via Python. And then you can do relevant, I mean, competitions, or like you can gear up for the interviews also. So I think that's how you can start out as a fresher.
Okay, sounds great. Also wanted to check that can someone from a non-tech background take this up? It's a very generic question, but yeah.
Yeah, I think it works for anyone, anybody, even from the non-tech background, because it's as simple as speaking English, which I just highlighted. So yes, definitely it makes much more sense. I mean, even if you're like from a non-technical background and you're trying to switch into this, initially it might seem a bit of a challenge because you might be new to understanding few of the concepts. But given the size of the community and the help that's already out there, it shouldn't be that difficult.